Hi everyone, welcome to Massey Dialogues, a series by Massey College focused on interdisciplinary, intercultural, and intergenerational discussion that's intended to nourish learning and serve the public good. I'd like to acknowledge that Massey College is built on indigenous land, the land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. My name is Chen. I'm a fourth-year PhD student in chemical engineering and applied chemistry at the Department of at the University of Toronto, and a first-year resident junior fellow of Massey College. Tonight, I'm fortunate enough to be your host. So what's our episode tonight about? As our viewers sitting at home certainly know, our country faces a pandemic threat unprecedented in scope, novel in origin, and distinctive in challenge. To mitigate COVID-19 means to evoke responsibility and grit. We each have a part to play. Members of the general public must embrace and maintain physical distancing. Healthcare workers will continue their diligent, courageous work. The public health community must elucidate the disease and facilitate its management. Our elected officials should make proper, data-driven decisions and engage with all stakeholders. Workers and essential businesses have to keep our communities running. Those in industry must produce essential supplies in critical shortage and support healthcare in all capacities. The academic community must, at rapid pace, use our capabilities to understand this infectious disease, develop novel solutions, and identify scientifically rigorous paths forward. And broadly speaking, we must work collaboratively across sectors, disciplines, generations, and traditional boundaries to best battle this landmark disease. Tonight's episode covers key aspects of this all-hands-on-deck response. For a more unique perspective, we look not just at what we know or what we're doing to respond, but importantly, how our response has and will come together. Through discussion with our distinguished guests, we'll explore a range of interesting, pertinent topics. By the end of this episode, I hope that our viewers will better understand the scope of our country's response, the behind-the-scenes actions being taken to help move us towards the best-case scenarios, and how collaboration can help overcome immense challenges. Just a quick technical mention. Please note that you can use the chat function on YouTube to submit questions. We won't be able to see the questions as you submit them, but later on in this hour, our technical team will forward them to us for discussion. And on that note, I'm very excited to begin our program and introduce our first distinguished guest, Dr. Natasha Crowcroft. Dr. Crowcroft is a public health medical practitioner with more than 25 years experience in public health at the local, national, and global levels, and 2 decades of senior management and leadership experience in infectious disease surveillance, prevention, control, and outbreak response. She's published over 250 peer-reviewed papers, including those in The Lancet, the BMJ, and the New England Journal of Medicine. From 1997 to 2007, Dr. Crowcroft was a medical consultant in the immunization department at the National Centre for England. In 2007, she was recruited to Canada to be one of the founding members of the leadership group at Public Health Ontario, helping rebuild our public health system post-SARS. She became Director of Surveillance and Epidemiology in 2008, Chief of Infectious Disease in 2012, Chief of Applied Immunization Research and Evaluation in 2015, and Chief Science Officer in 2019. In 2019, she also launched, as its inaugural director, the Center for Vaccine Preventable Diseases at the University of Toronto, where she's a professor at the Dalla School of Public Health in the Department of Laboratory Medicine and Pathobiology. And very importantly to us, she's also a senior fellow of Massey College. Dr. Crowcroft, it's an honor to have you on.
Thanks very much for inviting me today.
No worries. Would you mind if I called you Natasha, Dr. Crowcroft?
No, that's fine. Thank you.
Great, thank you. So to start us off, could you introduce the discipline of public health and describe what its role is during this pandemic?
Absolutely. Well, one of the definitions of public health is the art and science of keeping people healthy through the organized efforts of society. It's a very simple version of it, but it's essentially all the things that it's one of those things that you miss it if it's not there. If there's no public health system in place, you find out about it really quickly. But when it is there and it is working, it's almost invisible. And the way in which it's played a part in this terrible pandemic is right from the very beginning. So in China, all the systems around identifying the fact that this outbreak was starting in Wuhan, the identification of the virus that was involved, the alerting systems and the tracking of what was happening in that epidemic, and all the tracking that's gone on, surveillance of the disease that's gone on since then, is all part of our public health system. And it has many, many layers to it, starting at a very local level with individual clinicians and patients, where there's a requirement to report about an unusual disease, filtering all the way up to regional level, national level, global level. And there is international law surrounding how that system works as well. And so this was one of those diseases that fell under the international health regulations, which is a set of regulations that countries have signed up to express their desire to work together against common threats, such as things like pandemics.
That's very interesting. And so you mentioned the beginning in terms of the key role that public health has. So when a potential outbreak presents, how is our public health system designed to assess it and respond? And importantly, how does it consider that relationship between overreaction and underreaction when both of those choices can be highly criticized?
Yeah, that's a really interesting question. In general, we try and aim for identifying early and erring on the side of looking for unusual patterns very quickly in infectious diseases and jumping on them and trying to figure out what's going on very quickly. It doesn't mean that you set out the alert and get everybody panicked in the public, but it means within the public health system, what's supposed to happen is that if there's any kind of unusual cluster of disease, public health is supposed to know about it very quickly. And the public health laboratories are absolutely critical in that process, because they are the ones who will often be the first to say, well, what's going on here? We're getting all these requests for tests for something, and it looks like a pneumonia, but we don't know what it is. It's not coming up positive, it's not influenza, it's not flagging what is going on here. The laboratory system is really, really critical. The other thing that's often the very first source of information, which we saw in this pandemic, is a very astute clinician who will raise the alarm and say, listen guys, I'm seeing patients that just don't look like what I normally see. I'm seeing patients with a pneumonia, I don't understand what's going on. It looks like it might be SARS. I think we need to do something. Those people are incredibly critical, they're really, really important, and we need to listen to them. And there have been examples in SARS and in this pandemic where people raised the alarm and they were not listened to or even shut down. And in both the SARS outbreak in 2003 and in this coronavirus outbreak, those whistleblowers have actually died after having been ignored. So, we really need people to be able to speak out, and that transparency is incredibly important for all our safety, because in these kinds of outbreaks, you really need to jump on them incredibly early. Every delay, and this is where you were talking about the risk and of causing a problem. When it comes to epidemics, you need to act early and act swiftly. And you may not know at the beginning what the right thing is to do exactly, but you usually have an idea of what kind of thing you're dealing with. Like, you might not know exactly the virus, but you might, you can usually guess, oh, it looks like it spreads somehow in the respiratory way. What do we need to do to contain this? Who do we need to tell? What tests, what laboratory investigations do we need to start doing? And you have to do that early. You have to be really aggressive early if you're going to contain any epidemic.
Mm-hmm. It's very interesting that you mentioned all of these different roles that all of these stakeholders have, from virologists and microbiologists in the lab and other people, to clinicians who are seeing some of these patients present for the first time, as well as the epidemiologists who are modeling this information. And so there's a lot of information coming together, and there's a lot of collaboration. How does the information flow in terms of getting a lot of this information together and getting it to the hands of decision makers who then can act on this information? How does it come together?
Well, in the routine scheme of things, the public health system needs to be connected with the decision makers. So there are processes in place in what I would call peacetime to make sure that all the public health folk are connected to the decision makers. The actual model, the way in which that happens, varies a bit from one country to another. So in a decentralized federation like Canada, each province and territory has its own set of public health structures and its own centralized organization of some kind. But how that works across Canada varies. Some of the bigger provinces will have a center, and the independence of that center varies, but all of the centers are connected to government in some way. And that's where the political angle comes in, where politicians and political processes are incredibly important there as well. in order to make sure that politics doesn't stand in the way of public health, it has become a kind of standard, a good standard for there to be somebody in the system who's got an independent voice, who's a decision maker, who has the freedom to speak up and say, hey, listen, we've got a problem, and actually go to the public if the government's not moving. And that sort of power is really important, and that's personified in, for example, in Ontario, we have a chief medical officer of health. For Canada, we have a chief public health officer, that's Dr. Theresa Tam. Each province has a slightly different model, but they all have a chief public health or medical officer of health of one kind. And that role is as really the bridge between the information flow that's coming from the public health system into the government. And what we've seen in this pandemic, the definition I use for public health, I purposely took a definition that uses that wording, the art and science, because it's not, the science is only one piece of this puzzle. We need scientific solutions for sure, but you can see all around us that what's happening in this pandemic is there's this huge social and economic impact that we're necessarily having in order to try and save lives. And so these decisions we're making, they're not just about, what's the right thing to do to prevent COVID. It's also, they're huge decisions about what do we do about equity? How do we make sure we protect the most vulnerable? How do we make those decisions? How do we protect the healthcare system? How do we protect our healthcare workers? So, and how do we protect society and the economy? Because if you damage the economy irretrievably, then people will come to harm. Their health will be damaged as a result of that. So we don't want to solve one problem and cause another problem. We need to somehow have some balance. So your question about how the decision makers get their information, on the surface it's quite a simple information flow, but on another level, there's a very complex play of different people and different components of not just the health and public health system, but of the whole political and societal system to try and get the best possible result for everyone.
Okay, so it's not only people that are concerned about the disease, but also, say, economists and social scientists that are involved in putting their input and really building this general plan of how to move forward?
Yeah, absolutely.
Okay, great. That's very, very interesting. And just to jump on another note, we've our junior fellows, speaking at a distance, have been discussing the topic for quite a while. And one of the questions that we haven't that we've had, and one of the topics that we haven't been able to really quite wrap our heads around is this idea of this basic reproduction number, or R naught. So the R naught is supposed to be this value that says for every person that gets infected, on average, how many people do they infect? And for the SARS-CoV-2 virus, it's estimated at the early stages in a country about 2 to 3. And while that's certainly a very large number, and larger, say, than the seasonal flu, from what we understand, there's a large number of infectious diseases with an even greater R naught. And so why has this virus been spread and been such a significant outbreak?
So it hasn't got the highest R naught in the world, but it really doesn't matter. As soon as you have a basic reproduction number that's over 1, you will see exponential spread. It's the exponential piece that's important. So if each person infects 2 or 3 other people, then it means that the disease will spread. It's a mathematical phenomenon that the disease will spread exponentially, which means you don't have 2 people infected and then another 2 people infected. You have, for example, if it were 2, it doesn't go 2, 4, 6, 8. It goes 2, 4, 8, 16, 32. Like it's much, much faster spread. And you see, it's slow at the beginning when you look at an epidemic curve, which are these curves that it's fascinating to see, because epidemic curves, which kind of bread and butter for practicing public health physicians, are now becoming very familiar to everyone because they're in the newspapers every day or in the online in the media. So you see that flat piece at the beginning of the curve, and then it takes off very rapidly after that. I wouldn't, the fact that it sounds like only 2 or only 3, the bottom line is it's exponential epidemic spread, and we need to get that number down to 1 under one in order to stop that happening. The other diseases that are much more infectious are diseases like measles, which is incredibly infectious. But we have a vaccine for measles. We don't have anything for this virus. So the fact that it has a lower basic reproduction number, when you have a totally susceptible population, means we have absolutely no resistance to it. So it spreads really quickly because every single person it meets it can infect. Whereas you have measles with a basic reproduction number of possibly up to 18, which is a much bigger number. But if you have a case of measles in Canada, the chances are that 95% of the people that would get exposed to a case of measles would already be immune, so it's not going to just not going to spread. So it's a very different situation.
Mm-hmm. And so, Natasha, you mentioned vaccines while describing that, and I know that a tremendous amount of your work your research revolves around working on vaccines. Can you explain a bit about the role that vaccines have to play in this pandemic, and a bit about your work as well?
Sure, absolutely. So we hold out great hope that vaccines are going to be the solution to this outbreak eventually. And there's a whole raft of them under production. More than 50 potential vaccines have been sort of in the works somewhere. They're all at relatively early stage, but the revolutionary thing that's happened is how quickly progress is being made. So from sequencing the virus, which is what had to happen first before any vaccine could be made, to the first vaccine trial starting was 10 weeks, which is like unheard of. And many of the processes that normally happen in parallel, because it's more normally happening in sequence because they're so expensive, they're happening in parallel because there's such a rush on to try and get as many vaccines as possible out there and tested. But with the fastest systems in the world, we're going to struggle to see a vaccine ready for scale up and production. I mean, people have talked optimistically about 18 months maybe, but that would be phenomenal. Like, that's never happened in that kind of time scale before. So we don't really know when we're going to see them. One of the really good things is that there are so many different approaches being taken. So we've got the first mRNA vaccines coming out. So these are RNA vaccines using the messenger nucleic acids that are the sequence of the part of the virus we think may be protected. And these vaccines have been researched for some time, but this is the first time we're really trying them out in humans. So that's a big first, and that's one of the early vaccines is that type of vaccine. In fact, we have every kind of vaccine technology that almost you can think of is being used in this attempt to get a vaccine that works, including some live vectors. So one I'm particularly interested in is a measles vaccine virus with the antigen from this coronavirus inside the measles vaccine virus, which I think is a wonderful idea, partly because one of the big worries right now is that all around the world our routine immunization programs have been disrupted by this pandemic. So there's a real fear that one of the unintended consequences of the pandemic will be big outbreaks of other diseases because we haven't been able to keep our other public health systems going. So if we could come up with a vaccine for the coronavirus that also addresses one of our other public health challenges, then it'll be a double win. Anyway, there's a huge range of vaccines being produced. And if several of them are successful, I think that will be a good idea as well, because we don't know what's going to work best in the field. We don't know how we're going to scale up production. There's a lot of engineering questions that still need to be addressed.
And so you touched.
Science is just the beginning of. Sorry, the science is just the beginning of it. Like, there's some fascinating science going on. But the bit that I think in particular I'd like to emphasize is engineering, because when it came to the eradication of smallpox, there's been a lot of attention on how a smallpox vaccine was originally developed and the amazing fact of having a smallpox vaccine. But the way in which eradication was achieved was by people who were more on the engineering end of things, people who invented freeze drying of vaccines, who invented the bifurcated needle, the jet injector. These are engineering solutions to be able to scale up and immunize millions of people. And that that bit of the whole project is a really fruitful area for collaboration with other disciplines in public health.
Mm-hmm. Yeah, that's very interesting that you mentioned the role and the importance of research throughout this pandemic to not only understand it, but also implement solutions and help us move towards our best case scenarios. So you mentioned that number 18 months, and I know that's a number that's been popping up throughout the news quite a bit. And another number that's been popping up is perhaps 24 months, so that we hopefully not, but we may have to endure this pandemic in one way or another until, like you mentioned, we get a vaccine. Can you describe, based on our current best projections, what life may look like throughout these upcoming 18 or 24 or however many months?
I wish I could. Mm-hmm. I have to say, one of the things I think will really help us figure out what's going to happen is we need to get an antibody test validated, because there are some indications that there may be much more infection out there, or may have been many more infections in the community than we're aware of. Certainly, I'm currently in Ontario, where there's been much less testing than we would have hoped for. And what we really need to do is some sero surveys to look at antibodies in people's blood and see whether, in fact, there's been more widespread transmission in the community, because we need to figure out, given the basic reproduction number of this virus, we can work out that probably more than half of the population would get infected if we just let this infection rip through the whole community. Could be up to 60% could get infected if the virus was just allowed to spread. But then it may be that we're quite a long way along that pathway, or it could be that we've got a long way to go. So without that information, we're really flying blind at the moment. What we do know is right now, the measures we're taking are slowing down the progress to the peak of this epidemic. And if we haven't reached what would be the natural peak, as soon as we take off those measures, we would expect the virus transmission to start up again. So what we might see, if we're not close to that peak, is months of having to maybe relax the measures a bit, and then we'd get more transmission, and then we put them back on again, and then we get less transmission. You could end up with these cycles going on for some time, just depending on how much immunity there is in the population.
That's very interesting. Thanks so much, Natasha. We'll for our viewers back home, we'll see Natasha back during our group period, our question and answer period. And on that note, we'll move to our next section. And I'd love to introduce our second distinguished guest, Flavio Volpe. So Flavio is the president of the APMA, and the APMA stands for the Automotive Parts Manufacturers Association, which is Canada's national association representing OEM producers of parts, equipment, tools, supplies, and services for the worldwide automotive industry. He's a champion of Canada's globally relevant automotive sector and is dedicated to its growth, the development of new markets, and the leveraging of its international leadership. Flavio regularly speaks on behalf of industry interests, opportunities, and challenges in Canada and abroad, and is a sought-after voice by leading global publications, including The Economist, The New York Times, The Wall Street Journal, BBC, CNBC, The Globe and Mail, and The Washington Post. Flavio was recognized as Industry Leader of the Year by Automotive News Canada in 2017, and again in 2018. Previous to the APMA, he served as Managing Director Canada of Rusal AG, the EU's largest privately held solar photovoltaic energy developer, and as Chief of Staff to the Ontario Minister of Economic Development and Trade. Flavio, it's also an honor to have you on. Welcome.
Thanks for having me, and I graduated from U of T in 1997, so always happy to be part of the community.
Yeah, in that case, it's great to have you back on. And to start us off, can you begin by introducing what medical instruments and supplies are now being and in the future will be produced by auto supply manufacturers?
Sure, let me give a quick context of why auto suppliers are making these instruments. Early this month, I think most of us in this sector had spent the last 2 years fighting in a NAFTA negotiation with the American administration, and then, of course, together with the Mexicans, very in tune to international dynamics of trade, and started to see export restrictions from trading regions that are usually our best trading partners. The EU, on the weekend of March the 13th and the 14th, put export restrictions on medical devices, life-saving devices like ventilators, but also personal protective equipment. So we picked up the phone and spoke to our friends both in Ottawa and at Queen's Park and said, look, you've got two issues as we see them here. Number one, we're short of supply. Number two, you don't make them here. And there's a very healthy medical technology sector here in Canada, but they don't manufacture at the scale required to react to a virus whose spread is exponential. So what we suggested was we could partner together. We could lend in, I represent 300 companies that have 1,400 factories, mostly in Ontario and Quebec, but also BC, Manitoba, and some in Nova Scotia. We said we make product at a very high engineering tolerance at very high scale. We could partner with medical technology companies that own the IP, do it under contract manufacturing. We can make just about anything. The challenge is time. How quickly do you need ventilators? How quickly do you need PPEs? Everybody's looking at shortages and things like N95s. What can we do? Well, in the course of the last 3 weeks, of course, everybody stopped buying cars, and then the spread of the virus has caused, in all the jurisdictions where we operate, some version of shelter in place or other public restrictions on movement. So the factories that we offered we were offering space are now idle. So we've also said, well, beyond space, look, everything is possible. We started conversations with medical device companies around the world, headquartered around the world where the IP resided. And a lot of those were fruitless, meaning those companies that said, look, we're going to try to handle the global demand from our current structure. And I really don't understand who this guy is that's calling from Toronto that says you can organize a manufacturing partner. It's irrelevant to us. We found a few partners in the ventilator space, a company called O2 Medical in Brampton, and we found another GTA company called Thornhill Medical. And what we said was, we'll lend in the horsepower, the working capital, the workforce, the manufacturing know-how, the engineering know-how of the biggest companies in our space, Magna, Linamar, Martin Rea, Woodbridge, ABC, do about $60 billion of volume automotive parts supply annually. And so we were able to convince these two companies and the province of Ontario, as well as Health Canada, that we could make in very short order 10,500 life-saving ventilators now, with deliveries to start this month. Of course, we're all expecting a spike here in the next week or two. It's part of that blend of getting those in. But today I reviewed a list of 79 companies that are either now in production or just shorter production, meaning within a week or two of surgical masks, N95 masks, face shields, gowns, sterilization equipment. And they'll all be made here. The companies aren't shifting to a long-term strategy on medical devices and medical products. The volume difference in scale is 100 to 1 on automotive. This isn't income replacement, but this is the lending. I've been calling it the last few days the greatest peacetime mobilization of Canada's industrial might into public need. And we saw the Premier of Ontario yesterday go pick up ASTM level 3 masks at a company in Vaughan that 2 weeks ago was making headliners and trunk liners for Ford and General Motors.
Well, it's great to hear that all these companies are just jumping on ship and really helping out in any way that they can. And you mentioned a bit of involvement from Premier Ford. Can you talk a bit more about, there's from one standpoint, there's a lot of energy about producing things, but from another standpoint, we've got to make sure that it's up to par and that we're delivering to our healthcare workers stuff that has been standardized, is of high regulatory status. So can you talk about the role of the government in your relationship?
Sure. So all of these, the premise for public procurement, of course, is a Health Canada spec on product, and in some product classes, a Health Canada spec on production lines. So the shortest cut the shortest cut to achieving public good on ventilators, for example, is to work with existing companies and not try to engineer backwards and go get approvals, because certainly nobody at UHN would be purchasing a ventilator made in a garage. So on those ones, we worked with existing manufacturers and we said, what's your annual capacity for production? 1,000, 2,000? So we'll work with you to do subcomponents and supply chain and optimization and manufacturing optimization and expand your number tenfold. On other products like masks, I'll use this Woodbridge Group one as a good example. Woodbridge Group had a partner company called Inuak in Japan that is 2 months ahead, of course, because of course Japan's been dealing this with a little bit longer than we have. Went and got ASTM3 certification on this mask design, and it started a production in Japan. 10 million units have been delivered in Japan already. Here, of course, they don't have a medical license and they don't have certification. And so what we did is we talked first with Health Canada and with Ontario Health, and then we paired up with McMaster University. So while we were waiting to get the product prototypes into labs, and of course the world is trying to get into the finite number of labs that are available around here. So the quickest wait time that we had was 30 days in a lab in Michigan. We started to work on validation and performance testing with McMaster's engineering department. Speaking with government at the highest levels, Premier, Health Minister, Deputy Ministers, and all the officials down, said, what do you need to see for certification? Is there a path for an interim certification based on a validation by a third-party Canadian university? Does that lab there have something akin to international certification standards? And on that product, we were able to get, after 2 weeks, a Health Canada license for that product with a patchwork of SGS Labs and McMaster Engineering and Health Canada. And we got the product into production 2 days ago. And so while we cut all those times down, we didn't skip any steps. But you also, of course, this comes down to individual human beings. You can cut those times down on specific products, but there's a finite amount of number of human beings you can do it. So that's 20 less people to work on a gown program that we're working on with a company called Automotive that up until 2 weeks ago was making airbags in Tilbury. So we end up staging, and so in that staging, I'm a car guy. We make cars. We don't set the prioritization, of course, of which products and which classes of products and what volumes are. We're taking direction, of course, from a cadre of advisors that include public health, federal and provincial officials in health, and the central agencies, the Premier's office, Prime Minister's office. We in many cases, the reason that we're the solution, although it's not exclusive to us, but the medical technology companies are set up for the annual demand for these medical products, and the current demand, exacerbated by export controls. We saw the mess this week with 3M and President Trump. Is how do you quickly access that capacity at scale in the province? And so this company that was making trunk liners would be making 800,000 trunk liners a year. And could they make 1 million masks a week? Well, they could do it before a startup can. And if we're trying to relieve the pressure on the short supply of N95 masks for attending physicians and techs and nurses, and that we want to get as many ASTM level 3 masks out there so that we can help mitigate that, then that's what we focused on here. That same company is trying for N95, and to your point about certification, that process is deeper and involves more partners. We're not sure it can get there. The company hasn't banked on it. It's trying, and we're probably 3 weeks out from an answer on that. And so until then, all we're dealing with is prototypes and testing, and hasn't committed to building a batch that may or may not make it.
Makes a lot of sense. And as an engineering student, I can certainly appreciate the sheer scale and magnitude of retrofitting large factories like this and building products that meet specs. And on that note, we've been hearing a lot, like in the news and more from what you've been discussing in terms of us being able to make all these different critical supplies and instruments. Is there, and I know this is a complicated question because it's consistently evolving and it's a very dynamic equation, but is there any sense of when our automotive and auto parts and other industries where our manufacturers can start to produce enough supplies that some of these shortages, essentially that usage may no longer outcompete supply?
So on the simpler implements, like a mask or a face shield, very quicker, a shorter path, and a quicker manufacturing process per product allows for volumes of millions within the next week or two, which on the face shields, given the guidance that we got from procurement in Ottawa, we think we could meet the aggregate face shield demand of all the various provinces and territories within probably 10 to 15 weeks. Wow. And getting there in really big chunks along the way. That's current need. We don't know whether that means procurement would like to continue to procure them locally, or whether that gets them outside of a window where they can go back to whatever their global sourcing was. Of course, we predict. I guess we'd have to predict where we all are in 2-3 months and whether our sector's back at work. But it's really just a percentage of our sector. We could continue building this forever. It's probably 1 or 2% of the output of our annual sectoral output. So, if we wanted to have a captive domestic supply, we could do it. On the bigger, more complex assemblies, like ventilators, the thing as a layperson that we see in the jurisdictions where the healthcare network's been overtaken, it's usually because the need for ventilators exceeds the supply. We're in a kind of a rush against time on that one order for 10,000. Maybe the first batch of 1,000 or so gets delivered in a month. And the things that you can't rush is that on those complex assemblies, because it's not a one-shot mold or a laser cutting, where the electronic motherboards come from sub-suppliers that are outside of the country, important sensors that the entire planet is trying to buy, you've got 2 or 3 week lead times. So you can set up a series of substructures, but you got to wait 2-3 weeks for those pieces to come in. And once they start flowing, it's a flow. But you waste the first 3 or 4 weeks. Given that the ventilator business isn't our core business, the other thing that was very important was to find whatever competent, accredited local manufacturer there were, and the 2 that we did find are very, very small volume. And so what we're also doing is ramping up that volume. It's another engineering challenge in and of itself.
Okay, great. And on that note, thanks very much, Flavio. So for viewers at home, we'll move to our final segment now, which is a group discussion. And we'll take questions that have been submitted through the chat, and you can continue to submit your questions, and we'll discuss them. And so you'll see the questions actually pop up on the bottom of your screen, and we'll read them out. So a question from our principal, Nathalie de Rosier. So a question for Natasha. Should we be worried that every 2 to 3 years we'll have potentially a new virus that can devastate economies and populations? And how do we come to terms with not knowing that this is coming?
This is a very unusual event, and it's a once in 100 years type event. The last one that was this severe was in 1918, so almost literally 100 years ago. But we did see it coming. That's the bad news. We knew this was going to happen. One of my biggest concerns is how do we don't have new lessons to learn from this situation. we had all the lessons we needed. We had all the recommendations we needed to be properly prepared for this before it happened. We just didn't act on them, or we didn't stick with them. And that's the really huge challenge we haven't talked about at all. So that's why your question's really prescient. How do we make sure that this doesn't happen again? I said it was a once in 100-year event, but actually with the way the world is going, it may well be that the next virus comes more quickly, because we've changed the world in ways that means that it probably, the next time probably will be quicker. And that's because of things like the changes to the environment. The shortage of land means that we're having more exposure to animals, which is where most of these emerging viruses come from. It's through that connection with animals, including endangered species, and changes to the environment that bring animals that don't normally come into contact with human beings into closer contact, including intermediate animals. So in this case, we think it was a bat virus that came through another species into human beings. So there is a risk that the next one will be sooner. But the idea that we were not, so I think it is true we were not ready for this, but the tragedy is that we knew we were not ready. And we had reports back years. In fact, the Chief Public Health Officer of Canada, Dr. Theresa Tam, was involved in writing a report on what we needed for pandemic planning. We had all the lessons out after SARS. We had the warning of SARS. We had the warning from the MERS-CoV outbreak that happened in the Middle East. We've been here before, but every time these things happen, it seems like afterwards everyone just wants to move on and forget. And it's kind of the curse of public health. Like, everyone notices public health when it's not there. But when it is there, people say, well, why are we spending money on this public health thing? Like, what's the point? It's not doing anything. Forgetting that when nothing is happening, that's when public health is doing its job. That's a hard lesson to remember.
Mm-hmm. And I hope that's one of the positive outcomes whenever this terrible event is all over, that we'll recognize the importance of public health and continue to recognize that. So this is a question, again, for Dr. Crowcroft, for Natasha. So it's from a Pankaj Mara. Could this pandemic have been better controlled through global coordination, especially at the political level?
I think that's always the answer to that is probably always yes. Could the outbreak have been detected earlier at the very beginning and contained earlier in the very beginning? We would hope possibly yes, that might have been the case. Having said that, this virus has shown that it is very good at spreading in a susceptible population the way it has, and so it seems to have been perfectly adapted to become a pandemic. Even really very well developed public health systems have been hit hard by it, and some have done better at containing it than others. But I don't know. I couldn't. It's not clear cut that absolutely it could have been contained at the very beginning if action had been taken earlier. But it's definitely one scenario, and the early response could definitely have been better than it was. The whole international health regulations are really an agreement for countries to work together, and they rely on trust and mutual cooperation. And they were developed post-SARS, that back in 2005, they were signed off. They come from that. They originated right at the very back in history, the very origins of the World Health Organization and the United Nations, in this idea of global solidarity and countries working together. Right now, we have a real challenge globally, because that's not the environment we're in. I mean, we just heard about, from the engineering sector, the challenges in the motor industry with NAFTA. We're not in that world where people are collaborating together, where countries are trusting each other and saying, we're all in this together. Countries are much more looking after themselves. It's going to be really interesting what happens when vaccines are available, because do we think if, for example, our neighbour to the south If they get a vaccine that works first and they start scaling up production, are they going to share that vaccine with Canada? If Canada gets a vaccine that works first and we have production facilities here, are we going to share the vaccine with other countries? A government's primary responsibility is to look after its own population. It's going to be really interesting to see how this pans out and whether countries do collaborate and say, okay, we're going to share vaccines. We're going to share in the way that science has really stepped up in this, and the engineering sector. I mean, we've just heard from Flavio how many different sectors are stepping up and collaborating and sharing and saying, all right, we'll give you our IP. We're sharing this information. We're publishing our papers for everyone to read without any firewalls. The media is publishing things without any firewalls. Everybody's really. It's been heartwarming to see how everyone's been sharing. But I think the culture at political level in many countries has not been like that in recent years, and that is a challenge to political, countries and to political solidarity across the world.
Mm-hmm. So another question from our principal. What are the ways in which the industry will return to produce the next goods that we need? Is the industry learning to change production rapidly?
Yes, I think the short answer is yes. This first round of conversion to medical products also comes with it a whole bunch of quick learning. The first batch of PPEs that have come out are also getting very quick feedback from the end users, and usually in automotive, you build to a spec and it's out. I'm going to make 5 million of these over the next 5 years, and Bob's your uncle. We don't have that feedback loop that also has a redesign cadence. And what I've seen over the last 3 weeks is that everybody's thrown that aside and said, whatever the feedback is, as long as you're going to use it, if we're going to change it and you're going to use it properly, then we're in to do it. The real question for industry is, this is an industry right now that normally ships $35 billion a year of business. Can't stay closed for too long without it collapsing. The $35 billion of business can't be replaced by $200 million worth of PPE production. And of course, the federal government has stepped up and the provincial government has stepped up for income replacement and everything else. But those come from the taxes generated by commerce. So the real challenge for industry will be, the longer we stay, how much more difficult it will be to be that flexible. Are the companies going to be going concerns? The ones, certainly the big ones that have stepped up, have working capital for a while, but some of the really important regional ones that are making face shields, for example, I can name a few of them that won't be around in 3 months if we're closed. And so how do we manage that? I think Natasha talked about the cycles of, if we're in this for 18 to 24 months, do we cycle out and back in a way that kind of balances our ability to remain healthy in different ways? We don't know what the answer is. Certainly everybody's got some anxiety there, but we've got companies that are making PPEs, and we're also writing back to work protocols that if our automaker customers are signaling that they want to go back to work in May, how are we going to redevelop our workspaces so that everybody's safe from a health point of view? And some of that is consumption of the PPEs we're making. So does that then tighten the supply that we're able to put out into the public sector? So it's a whole bunch of quick thinking of never before scenarios that certainly there are going to be a lot of failures along the way. But what we're finding is, especially in Canada, the U.S. has different antitrust legislation, but in Canada, there's a real collaboration between these companies and the automakers themselves and both levels of government to just say, look, we'll just figure out the solution. Where we need to insert public finances, we will. Where we need to get help, for example, we've got the aerospace sector that doesn't build at this scale, has massive autoclaves. And so, hey, you know what? Maybe we don't have to make as many masks as we're envisioning. If the University of Manitoba and the National Microbiology Lab are right, that we can autoclave at 121 degrees and 100 pounds per square inch to make these masks reusable. We're learning at a pace, adjusting at a pace that even this industry is not designed to do.
Mm-hmm. It's very interesting that you touch back on that point, Flavio, that relationship between research and industry, and as Natasha previously mentioned, the relationship between research and really the rest of our medical response. And so now a question from the Canadian Business History Association. Natasha, how do public health officials deal with the Trumpian trade-off that the medicine is worse than the cure? You mentioned that economists are part of the team. Who are these economists?
I'm not sure I can answer the question, who are these economists, but there are health economists who are working with provincial level and at national level to try and advise. I know that the National Poverty Action Group is involved in trying to consider some of the issues here. The government of Canada and the provincial governments have been putting in mitigating things, which Flavio just talked about, some of the ways in which the government's supporting workers who are not being paid and who are having to be furloughed or losing their jobs. So there's a whole load of economic support that's going out to help people to make sure they're not really in real difficulty. I think right now we're in a situation where people are still trying to figure it out. I mean, this is a huge global experiment, to be honest. Nobody has done this kind of thing before on so many levels, but the social impact, nobody's ever imposed a change like this in really virtually the whole world. So what the implications are going to be for every aspect of our lives are just currently unknown. So in the same way, I think you're having to try to adapt engineering and get feedback and figure out how to make things and how to adapt the industry. We're going to have to do that socially as well. And it's very difficult, I mean, politically speaking, to try and make that call. We know that unemployment, poverty kills people. We know that social isolation kills people. We know that everything that's going on can be a risk to health. How do you weigh that in the balance against the risk to people of getting this infection, which for young, healthy people is relatively low? But can you say, okay, we're going to take the risk and we're going to send kids back to school, for example, and maybe this will be one strategy. Say, okay, we can't destroy the education of a generation. Should we be sending kids back to school in the fall and allowing them to get infected? But protecting the grandparents, protecting anyone who's at high risk because they have other comorbidities. You can talk about that idea in theory, but I can tell you that one child gets seriously ill with that strategy, and there would be an uproar. It would just not be socially acceptable. So there was a 13-year-old healthy child died of COVID-19 in the UK recently, and that kind of thing really shakes people. Obviously, it's not surprising. So it's easy to have those kinds of utilitarian kind of discussions of, how many people are going to die of poverty and how many people die of the virus. It's really hard when you know that the first person to die of COVID-19 following a change in policy is going to be on the front page, whereas it's much more hidden, the effect of, for example, isolation or of job loss. That is a much more hidden phenomenon. All the time politicians make decisions that lead to people being healthy or not being healthy. And a lot of those decisions are hidden, or they fall on the most vulnerable in society who don't have a voice. And so they're hidden in that way. And that's one of the big challenges in public health, is speaking up for equity and trying to make sure that we, to the best of our ability, protect people like that. But I can't give you easy solutions to this. And I think that's why we all need to be talking about these decisions and figuring out where we go next. And we also really need good information, and that goes back to the research question. We need good research that's telling us where we are in this outbreak, because going back to what I was saying about seroepi studies, serosurveys, like if we knew that we were pretty much there in terms of immunity in the community, we'd be much more confident about making a decision to relax measures. But right now, we're flying blind. We just don't know the answer to that question.
Great, thank you, Natasha. A question for Martha Trillian. After H1N1, 2 reports by the Public Health Agency of Canada as a leadership community concluded that the country's response to pandemics failed. And a Senate committee concluded the country's response to pandemics failed for miscommunication, lack of medical supplies, to name a few. How can all levels of government better respond to pandemics? I guess maybe that's a question to start off with for Natasha.
Yeah, I heard somebody asked a similar question recently, and their answer was that they actually asked the person, the interviewer, who was a journalist, to hold the government's feet to the fire afterwards. That from inside the public health sector, it's really hard. You can argue for more resources, but it doesn't happen. I mean, the last 2 years, public health in Ontario has been squeezed, and one of the first things that the new government did was start cutting public health, and that's a very common reaction of governments. Because they don't necessarily understand what it's for, what it achieves. And that's part of the history of the cycle of public health, and that happened under the Harris government previously, where public health was also cut, and that's one of the things that led to SARS. So the question, who can hold the government to account for this? Who is accountable for making sure we do act on our recommendations? And there are a few mechanisms. So one is that example I gave of asking the media to make sure that government doesn't neglect its duties. The other is society in general, that everyone can hold government to account and say, what are you doing about this? And I think that, so there are things that can be done. The Auditor General can also do that if they choose to, and understand what the right question is to ask. I think we all have a part to play in that.
Great, thank you, Natasha. So I know on my end, it seems like time has flown by unbelievably quickly. We have 3 minutes left in our program, and I'd like to give a moment for each of our distinguished guests to give a concluding remark. Perhaps we can start with you, Flavio.
Sure, and I think my remark will kind of tie into that last question. Look, we're in a new world. This is trying to predict what governments are going to do in different countries around the world. According to their own dynamics is always difficult, and it's always difficult to drive. This is the first time in history, at least in the history of the 24-hour news cycle and the internet, that we're all in the same place. And I think that much like we did on anti-landmine agreements around the world, some bold government or the United Nations or the WHO has to take an international position that says we're all going to agree to a certain percentage of spending on public health, specifically for pandemics, and that all signatory countries agree that X percent of every annual budget, whatever it is, 1%, will be for the implements of public health, and we all have a global need for our partner countries to spend the same amount in the same protocols, and we set some permanent body as part of WHO or the UN. Otherwise, like Natasha says, we're going to be here forever.
Mm-hmm. And Natasha, concluding remark from you.
That was a great point, Flavio. I'd like to try and end on a positive note and say, let's not let a good crisis go to waste. And there's a lot of positive things that can come out of this. It's a terrible situation in many ways, but these huge shocks to the system are also paradoxically opportunities to do things in a different way and in a better way. So let's all look for the positive things we can do to make the best of the situation so that we come out of this stronger and in a better place for the future.
Thank you, Natasha. So to end off our program, I'd like to thank our 2 distinguished guests for their insightful, interesting, and inspiring discussion. I'd also like to thank Massey College for giving me the opportunity to host such an amazing Massey Dialogues. And importantly, I'd like to thank our viewers and everyone else in Canada and throughout the world. for your involvement in this all-hands-on-deck situation. For a look to next week, also, I want to invite all of our viewers to check out next week's videos, or next week's Massey Dialogues featuring Chief Phil Fontaine on reconciliatory next steps, and featuring University Professor Anita McGann on new strategy for global health. Thank you again, everyone, and have a great night.